Okay, problem 10. Does the following limit exist? If it does, what is the value? If it doesn't, right, tell me why. Okay, so the first limit is the limit of this function, 6 over x minus 5, when x is approaching 5 from the right. Okay, in the answer, it draws a graph, but we don't have to draw the graph to make the conclusion. Okay, we can just write down the analysis and we can draw the conclusion from there. For example, when x is approaching 5, okay, from the right, okay, that means what? That means two things, right? Okay, that means two things. First, x is approaching 5, and second thing, x is always slightly greater than 5, right? Because you are approaching 5 from the right-hand side. This is 5. You're approaching 5 from the right-hand side. It's approaching 5, but it's always slightly greater than 5. Okay, then this is the behavior of x. Then what will be the behavior of x minus 5? Okay, you can see x is approaching 5. So x minus 5 is approaching what? Right, x is closer and closer to 5. So x minus 5 is closer and closer to 0. Right? And x is always slightly greater than 5. So x minus 5 is always slightly greater than 0. Okay? So that's the behavior of this denominator. Okay? So your denominator is approaching 0, but your denominator is always slightly greater than 0. Okay, and then how will this fraction behave? Okay, I'll write it down here. How will this fraction behave? Right, a number over something. Okay, you know this thing is closer and closer to 0. Okay, for example, it's 0.1, 0.01. You know, it's a sequence of number, and that sequence of number is closer and closer to 0. Then this fraction is going to be larger and larger, right, over time. Right. For example, here it's 0.1, then it's 60. Right. If it's 0.001, it's like 6,000. Right. When x is closer and closer to 0, this fraction is going to be larger and larger. Okay, and there is no limit for the increase. This fraction can be as large as you want. Okay, so that's why it is approaching positive infinity. Okay, it is approaching positive infinity. Do you have any questions about this part? Okay. So part B, similar steps. It's limit cosecant x when x is approaching pi from the left. So first, we are not familiar with cosecant, but we are very familiar with cosecant is just 1 over sine. Okay. It's 1 over sine. Okay. Then when we write it in this way, we can start our analysis. When x is approaching pi from the left, okay, that means what? That means your x is closer and closer to pi, but your x is always slightly smaller than pi. Okay. It's always slightly smaller than pi. Okay, because you are approaching from the left. Okay, let's say this is pi. Okay, you're approaching from the left. You're closer and closer to pi, but you're always smaller than pi. Okay. Then what about sine x? How will sine x behave? Your sine x, right? What is sine pi? Sine pi is 0, right? But when x is smaller than pi, right? For example, sine 179.99 degree, right? It's always slightly greater than 0. Right, sine 179.9999. Right, it's always slightly greater than 0. So sine x is approaching 0, and sine x is always slightly greater than 0. Okay. Then again, this bottom, right, this denominator, the bottom of the fraction is closer and closer to 0, but it's always slightly larger than 0. So let's say this is 0.1 now, then the value, if it's 0.1, then the value is 10. Right? If it's 0.001 now, it's 1,000, okay, etc., etc. So that's why this 1 over sine x, right, it can increase as much as possible, as much as you want. So the result is positive infinity. Okay. Do you have any questions for this part?